For this question, there are two chemical equations. The first one is ethylene will react with water and will become ethanol. For the second one, it will become the undesired product. So ethanol will further react and will become diethyl ether with a trace of water. You can see over here. So the flow chart of this question is like the diagram in the slide. There are three variables that into the reactor, as we can see over here, and 100 mole of basis as the basic of the calculation in this question. For the degree of freedom analysis, there are three unknown label variables minus with two independent atomic balance C and H, and one independent species which is inert gas. So we got 0. So this question is solvable. For the calculation part, we will use the atomic method. First of all, we will balance the carbon. So N0 times 2 mole of carbon over 1 mole of ethylene will become equivalent to 37.4 mole of ethylene times 2 mole of carbon over 1 mole of ethylene plus 4.5 mole of ethanol times with 2 mole of carbon over 1 mole of ethanol plus 0.2 mole of diethyl ether times 4 mole of carbon over 1 mole of diethyl ether. So we will get the number of mole of for ethylene is 42.3 mole. Meanwhile, for the hydrogen balance, N1 times with 2 mole of hydrogen over 1 mole of water plus 42.3 mole of ethylene times 4 mole of hydrogen over 1 mole of ethylene will equivalent to 37.4 mole of ethylene times with 4 mole of hydrogen over 1 mole of ethylene plus 4.5 mole of ethanol times 6 mole of hydrogen over 1 mole of ethanol plus 0.2 mole of diethyl ether times 10 mole of hydrogen over 1 mole of diethyl ether plus 46.6 mole of hydrogen times 2 mole of hydrogen over 1 mole of water. So we will get the number of mole of hydrogen is 51.3 mole. For N2, which is inert gas, so we will times with 100 mole of feed. So 0.113 mole of inert gas over mole times with 100 mole of feed. So we will get 11.3 mole of inert gas. Next, for the composition, so number of mole of total in this equation is 104.9 mole. So the composition of ethylene in this question is 42.3 mole over 104.9 mole times 100% equivalent to 40.3%. For water, 51.3 mole over 104.9 mole times 100% will equivalent to 48.9%. For inert gas, 11.3 mole over 104.9 mole times 100% equivalent to 10.8%. For the combustion part, moles or reacted of the feed of mole reacted of the product over moles of feed times 100%. So 42.3 mole minus 37.4 mole over 42.3 mole times 100%, we will get the 11.58 conversion of ethylene in this question. For fractional yield, how to calculate it? Mole of desired product over moles of reactant feed. So 4.5 mole over 42.3 mole, we will get 0.106. So for the selectivity part, we will need moles of desired product over moles of undesired product. So we will get 4.5 mole over 0.2 mole equivalent to 22.5. For extent of reaction method, the degree of freedom analysis, there is 3 unknown labeled with plus 2 independent reaction minus 4 independent reactive species minus one independent non-reactive species will get 0, and this equation is solvable. We use this formula in this slide to get the answer. So by using that formula, 0.374 mole of ethylene over mole times 100 mole will equivalent to number of mole of ethylene minus weight Z1. So we get number of mole of ethylene equivalent to 37.4 mole plus Z1. This will be our equation 1. For the next one, 0.466 mole of water over mole times 100 mole will equivalent to number of mole of water minus with Z1 plus Z2. So we will get number of mole of water equivalent to 46.6 mole plus Z1 minus Z2. This will be our equation 2. For the next one, 0.05 mole of ethanol over mole times 100 mole will equivalent to 0 because there is no reactant plus Z1 minus 2Z2. So we will get Z1 minus 2Z2 equivalent to 4.5 mole. This will become our third equation. Lastly, 0.02 mole of diethyl ether over mole times 100 mole equivalent to 0 plus Z2. So we will get Z2 over 0.2 mole. So next, we need to substitute Z2, which is 0.2 mole, in equation 3. So Z1 equivalent to 4.5 mole plus 2 times with 0.2 mole. So we will get 4.9 mole for Z1. So after we get the Z1, we can substitute it in equation 1. So number of mole of ethylene equivalent to 37.4 mole plus 4.9 mole, which is this is the Z1. So we will get 42.3 mole. After that, we will need to substitute Z1 and Z2 in equation 2. So number of mole of water is equivalent to 46.6 mole plus 4.9 mole, which is Z1, minus 0.2 mole, which is Z2. So we will get 51.3 mole.